Hello everyone. In today's lecture, we will consider two-dimensional unsteady diffusion equation and we will discretize using finite volume method. In last class, you learnt the finite volume discretization of steady state diffusion equation and you have also learnt the assumptions made in different places. So, today let us consider two-dimensional unsteady diffusion equation. So, the equation is rho del phi by del t. So, this is your temporal term. Now, this term is added and in last class already we have discretized this divergence of gamma grad phi plus s. Okay. So, in last class this first term temporal term was 0. So, you know how to discretize these using finite volume method. Only now we have to see that how we will integrate in the time level. Obviously, we will new time levels will be extrapolated from the previous time level values. So, you can see that now we will define the flux vector j as minus gamma grad phi. So, the modified equation you can write is as divergence of j is equal to s. So, now this equation you integrate in this main cell P. Okay, this is your main control volume. So, in this main cell P we will integrate both over in volume and over time. Okay. So, integrating the above equation over main cell P and time interval from t n minus t n plus 1 minus t n. Okay. What you will get now? So, you will integrate over time. So, time from t n to t n plus 1. Okay. So, again over the control volume. So, this is your volume integral del rho phi by del t dv dt. So, this is the temporal term. The second term now you integrate over the time t n plus 1, then volume integral, then you have divergence of j dv, then dt, and then you have source term. So, that also you have to integrate from t n to t n plus 1, volume integral s dv dt. Okay. So, now first let us integrate over control volume each term. So, if you see the second term, this already we have learned how to discretize using finite volume method. Okay. What you do? You convert this volume integral to surface integral using Gauss divergence theorem and write the in terms of phase fluxes. Okay. And this also we have integrated using the finite volume method and we have used a average value at the cell center P. Okay. So, these two terms already we have learnt in last class how to discretize using finite volume method. So, now let us see this term. So, now let us integrate over the control volume. So, If you see this term particularly, then this term you can write as, say, in our case control volume is stationary, okay, stationary and CB stationary and non deforming. Okay. So, what we can do, we can write del of del t over integral over control volume rho phi dV. Okay. So, now you can see that now this value rho phi, you have to take the average value at the main cell P. So, that will take the mean value theorem and we will take the average value at cell P. So, we can write del of del t. Okay. So, we will take a average value. So, it will be rho phi p. So, phi p is the average value at the cell center P and rho is constant, only rho. So, into delta V. Okay. So, that we can write, and you can see now this value we have to integrate over time. So, that you can write d of dt rho phi p, okay, delta B. Okay. So, this is the first term, you can write this way. Now, you consider the second term. So, now we are not going to write in detail. So, you use the Gauss divergence theorem and convert this volume integral to surface integral and write in terms of phase fluxes. So, this you can write, okay, summation of f j f dot s f, okay, summation of all the phases. So, in this case we have 4 phases, east, okay, west, we have east, north, west and south. So, this way this will be just J E dot A C plus J W dot S W plus J north dot S north plus J S dot S S. Okay. Now, let us see the last term, which is your source term, and also we will use the average value at the cell center. Okay. So, all these you can see that we have used second order accurate scheme. So, this term, okay, only in this bracket, okay, we will write S bar delta V. Okay. So, all this term we have discretized using volume integral. Now, we have to integrate over the time. So, let us write. So, it will be now T n to T n plus 1 d of dt rho phi p delta V. This is actually volume of the main cell P. Okay. Delta V is nothing but, okay, delta V at P, and that is nothing but for this particular case delta x into delta y. Okay. The second term T n to T n plus 1 summation of f j f dot s f, okay, dt, oh here dt is missing. So, you have to write dt here, is equal to T n to T n plus 1 S bar delta V dt. Okay. So, now see, we have to integrate each term from the time level T n to T n plus 1. Okay. So, obviously, if you want to integrate, so we have to use some average value at tau, which tau may be in between T n and T n plus 1. So, the source term and fluxes are assumed as average value taken at a time level tau with T n less than equal to tau less than equal to T n plus 1. So, you can see that we are going from T n to T n plus 1 and we have to take the average value of the source term and fluxes at a time level tau. Okay. So, tau may be in between T n and T n plus 1. Okay. So, we can write now the first term. So, if you integrate, so you can see. So, this if you integrate over the time, so dt if you cancel, then it will be d of rho phi p and delta b does not depend on time. So, obviously, you can write rho phi p n plus 1 minus phi p n delta b. Okay. So, we are now marching in time from time level n to n plus 1. Okay. So, n is the previous time level and this is the present time level. Okay. Now, second term you see, so we will take the average value, okay, SF at time tau and as we integral over delta t. So, it will be T n plus 1 minus T n, okay, is equal to S bar delta V. So, this also we have to take at a particular time tau T n plus 1 minus T n. Okay. So, now let us say that delta t, the time step delta t is equal to obviously T n plus 1 minus T n. Okay. And so, now how will calculate this value of this fluxes and source term at time level tau. Okay. So, obviously, you have to take either from T n or T n plus 1, because you are having the values at time level T n or at T n plus 1, which is your current time level. So, all these fluxes and the source term you have to take the average between these 2 points. So, the average value may be calculated as follows. So, summation of J f dot S f at time level tau will calculate as 1 minus f t, okay, summation of J f dot S f, okay, at time level n plus f t summation of f J f dot S f, okay, at time level n plus 1. So, you can see we are considering this average value, okay, which is at time level tau, because we have the values available either at n time level or n plus 1 time level, because we are moving from n to n plus 1. So, obviously, we are taking a factor 1 minus f t, okay, of n time level and f t times with n plus 1 time level. Okay. So, obviously, you can see that f t is 0, then obviously, you will get only at time level n, and if f t is 1, then you will take only from n plus 1 time level. So, similarly, S delta V you can take as 1 minus f t S at n plus n time level plus f t at S n plus 1 into delta V. Okay. So, you can see f t lies between 0 and 1. Okay. So, f t is a factor, okay, which you are taking the average between n and n plus 1 time level values. Okay. So, let us put all the values now, rho phi p n plus 1 minus phi p n delta V plus. So, now you write 1 minus f t, okay, summation of j f dot s f. Okay, so, which time level we will take? It is at nth time level plus f t summation of j f dot s f f at time level n plus 1 and we have delta t, okay, is equal to, now source term we have 1 minus f t s n plus f t s bar n plus 1, okay, we have delta v and delta t. Okay. So, now you divide both sides by delta t. So, what you will get? Divide both sides by delta t. So, what you are going to get? Rho delta v by delta t phi p n plus 1 minus phi p n. Okay. Now, delta t we have divided. So, only we will have 1 minus f t, okay, 1 minus f t, and what is j f dot s f? So, we know already j f dot s f, okay, all the phases. So, j e dot s c plus j w dot s w, j n dot s n plus j s dot s s. So, that if you write, so you will get minus d. So, this we have derived in last class, okay, phi p n plus d w phi p minus, sorry, this time level do not write. So, phi p minus phi w plus d n, this is minus d n, and phi n minus phi p plus d s phi p minus phi s. Okay. So, this is the fluxes at the faces, okay, j f dot s f. So, that already we have discussed in last class. So, that we have just written here. Now, you put these values at n and n plus 1 time level wherever applicable. So, now you can see this is at time level n. So, you can write minus d e phi e. So, we are taking at time level n minus phi p n plus d w phi p n minus phi w n, then we have minus d n phi n minus phi p plus d s. So, this at time level n phi p n minus phi s n. Okay. So, now we have this term. So, you can write plus f t, okay. So, you can write minus d e. So, at which time level? At n plus 1 time level. So, phi e n plus 1 minus phi p n plus 1 plus d w phi p n plus 1 minus phi w n plus 1 minus d n phi n at n plus 1 minus phi p at n plus 1 plus d s phi p n plus 1 minus phi s at n plus 1. Okay. So, these are the flux terms and we have now this source term. Okay. So, is equal to 1 minus f t s bar n plus f t s bar n plus 1 delta v. So, now what we will do? We will take the values of phi p at time level n plus 1 in the left hand side and all other terms we will take in the right hand side. So, that we can write this equation in a p phi p form. So, you can see where we have phi p at n plus 1. So, this one, this and this. Okay. So, this we will keep in the left hand side and rest all other terms we will keep in the right hand side. So, we will write rho delta V by delta T. So, this is the first coefficient. Then if you consider this one, so you will have minus minus plus, so it will be plus dE. Okay. Then so d, but we will have ft here. Okay. So, you can write it as ft, okay, dE, then we have dw, okay, this is your dn plus this is your ds. Okay. So, these all are at time level n plus 1, phi p n plus 1. Okay. And now, rest all other terms you take in the right hand side. So, what we will write equal to, so equal to, now first you see the n plus 1 time level terms. Okay. So, we have, so f t and you see minus d phi. So, if you take in the right hand side it will become plus. So, you can write f t, so it will be d e phi e n plus 1, okay, then plus this one phi w. So, it is minus, so this side it will be plus d w phi w n plus 1, then we have plus this one. So, d n phi n n plus 1 plus this one d s phi s at n plus 1. Okay. So, all the terms at n plus 1. So, these you can see all are neighbor terms phi e, phi w, phi n and phi s. Now, you take the neighbor terms of at n time level. Okay. So, you can consider this term, this term, this term and this term. So, if you write it, so you will get 1 minus f t is there. So, 1 minus f t, okay, and we can write d e phi e at n plus d w phi w at n plus d n phi n at n and d n phi n at, sorry, phi south at n. Okay. So, this is all neighbor terms. Now, we have some terms phi p at time level n. So, this one, this one, this one and this one. So, this we take in the right hand side. So, if you take in the right hand side, you can see we have another term also phi p n here. So, all these you take in the right hand side. So, you can see, so this is your minus, so it will become plus. So, if you take right hand side, it will be rho delta v by delta t. Okay. Then you see this is your 1 minus f t, so it will become minus 1 minus f t. Okay. And again you can see this is your minus minus plus. So, obviously, right hand side it is minus and we have put minus here. So, you can write d e plus d w plus d n plus d s. Okay. So, this is your phi p n, and now the source terms. Okay. So, you can write f t s n plus 1 delta v plus 1 minus f t s bar n delta v. Okay. So, all other terms we have taken in the right hand side. Okay. So, this is the final algebraic equation. So, now let us write in terms of the coefficients. So, obviously, the coefficient associated with the phi p n plus 1, that is your diagonal coefficient, and that will represent at a p. So, we will represent as a p. So, this is your a p phi p n plus 1. Okay. So, this is your a p. Then you have right hand side. You see, you can write it as summation of all the face neighbored. You have all a n b. Okay. Then we have f t phi n b n plus 1. Okay. and also you have 1 minus f t phi n b at time level n. Okay. So, up to this we have written. Okay. So, now you write plus. So, this is your, we are denoting as A p 0, okay, rho delta v by delta t. Then we have minus 1 minus f t, okay, and this is your summation of n b, okay, all the neighbor. So, we have now phi p at n plus the source term b. So, this is the final algebraic equation which you need to solve, okay, and you can see we have the terms associated with n and n plus 1 time level. So, now what are the coefficients? So, we told that we have A p 0 is rho del v by del t, okay. What is A e? A e is your d e, which is we have already calculated gamma e A e by delta x e, okay. And A w is d w gamma w A w by delta x w. Similarly, A n is d n is equal to gamma n A n divided by delta y n. Okay. So, this is the difference between phi n minus phi p. So, and A south is d s is equal to gamma s A s by delta y s, okay. And we have A p. So, A p you can write as A p 0 plus f t summation of A n b, okay. And the source term b you have f t s bar n plus 1 delta v plus 1 minus f t s bar n delta v. So, now let us see some special cases where f t is 0, f t is 1, f t is half. So, if you can see that if you put f t is equal to 0, obviously you are going to get only the terms associated with n in the right hand side. So, obviously it will be explicit, and if it is f t is equal to 1, then you have both n and n plus 1. So, obviously it will be implicit, and if you put f t is equal to half, then you are taking the average of at time level n and time level n plus 1 values. So, obviously it will become Crank-Nicolson, and you can see that obviously explicit and implicits are these are first order Euler time integration we have done. So, it will be order of accuracy is delta t, but Crank-Nicolson is delta t square. So, now explicit scheme, special cases. So, f t is equal to 0, which is your explicit schemes. So, if you put f t is equal to 0, so obviously you can see A p will be your only A p naught, the source term will be s bar n delta v, and the algebraic equation will become A p phi p n plus 1 is equal to summation of all the neighbors A n b phi n b at time level n plus A p naught minus summation of A n b phi p n plus b. Okay. So, you can see only phi p n plus 1 is unknown, and all other terms are available at time level n. So, obviously this is explicit schemes, and it is very easy to code, right, easy and convenient to code, and but order of accuracy is delta t. Okay. So, order of accuracy is delta t. Now, you see f t is equal to 1. So, it will become implicit methods or implicit schemes. Okay. So, in this particular case your diagonal coefficient A p will become A p naught plus summation of all the neighbor coefficients. Okay. and the source term B will become S bar n plus 1 delta V, and the algebraic equation will become A p phi p n plus 1 is equal to summation of all the neighbors A n b phi n b at n plus 1, and we have A p naught phi p n plus b. So, you can see here n plus 1 all the neighbor coefficient, diagonal coefficients also all the neighbor values at n plus 1, the diagonal value phi p at n plus 1. So, obviously, it is implicit schemes and order of accuracy is delta t. Now, f t is equal to half if you consider, then it will become Crank-Nicolson method. Crank-Nicolson schemes. So, it is better to write scheme. Okay. Now, in this particular case, now A p will become half of summation of A n b neighbor, A p is equal to A p naught plus half of summation of all neighbor, and the B will become S bar n plus 1 by S plus S bar n delta V. Okay. And the algebraic equation will become A p phi p n plus 1 is equal to summation of all the neighbor A n b by 2 phi n b n plus 1 plus phi n b at n plus A p naught minus half summation of A n b phi p n plus b. Okay. So, you can see here now half of phi n b n plus 1 phi n b n. Okay. So, this will become order of delta t square. So, in today's class we considered unsteady diffusion equation in 2-dimensional situation, and we discretized using finite volume method. So, we integrated the governing equation over control volume as well as over time, and we wrote the fluxes, okay, when we integrate over the time as a average value at time tau. So, but the values at tau you can take the average from either t n time level or t n plus 1 time level. So, obviously, because at these 2 points we know the values of the variables. So, we took a factor f t where we have taken 1 minus f t times the fluxes at n time level and f t times the fluxes at n plus 1 time level, and similarly for the source terms. So, then we have discretized that equation and wrote the final algebraic equation, and also we have written the coefficients. As a special case we have put f t is equal to 0 and we got the explicit scheme where only one unknown is there phi p n plus 1, and when f t is equal to 1 it will become implicit scheme, and there are more than one unknowns at time n plus 1 level, and when we have put f t is equal to half, so it become Crank-Nicolson method. Okay. We take half from n time level and n plus 1 time level of these fluxes and the source terms, and the order of accuracy becomes second order. Thank you.